Welcome. These are the notes for Lesson 16 in Module 1 for Grade 7. We're going to be starting to talk about scale and scale factor, and in this lesson we're just going to start talking about enlargement and reduction. In example 1, we have two different problems, here and here. In each problem, A is the actual picture or the original image, and B is the drawing. We want to look to see is the drawing an enlargement or a reduction of the actual picture. An enlargement makes the drawing larger than the original, just like it sounds. And a reduction is making the drawing smaller than the original. So here in number 1, our original picture, or our actual picture, is smaller than the drawing. So the drawing is an enlargement. In number 2, the actual picture, here it looks like a ruler, the drawing is smaller than the actual picture or the original, and so it is a reduction. Keep in mind those two vocabulary words. We're going to be using them a lot. Let's move on to example 2. In example 2, we have two different maps. This is a map of a park that Derek's family went to, a modern public garden. He looked at the map of the park. There's a reduction of the map located at the garden entrance. Remember, reduction means it is smaller. The dots represent the placement of rare plants. The diagram below is the top view, so looking down, as Derek held his map while looking at the posted map. So here is Derek's map, because it's a reduction of the posted map. Here's the posted map. As you can see, they look a little different because Derek's map is held in a different orientation. It's turned around. The question asks, what are the corresponding points of the scale drawings of the map? So corresponding points, corresponding means matching. So if I looked at the points on Derek's map, A, V, H, and Y, what points do they match to on the posted map? Well, if I look at where point A is, here it's on this cross piece, short cross piece that seems to come all the way to the edge before turning at 90 degrees. If I look at the posted map and match that up with the same shape, I see a shorter cross piece that takes a 90 degrees. So it's A matches to point R. If I look at point V, it's on the long horizontal that goes all the way to the edge. If I look at point W on the map, on the posted map, it matches. The corresponding point to part H is where the two lines cross. If I look for two lines crossing on the posted map, that's point P. And point Y is on the edge of this curve here. If I look for the same shape in my map, I can see that point N is in the same place. Now, Derek's map has been turned 180 degrees from the posted map. If we were to rotate Derek's map again 180 degrees, we could see where the points match up. All right, so our new vocabulary word is corresponding. So far we've had 3: enlargement, reduction, and corresponding. These are going to be important words that we use as we learn how to do some other things with scale. Here in example 3, we have an outline of a building for a diagram she was making. And then Celeste drew a second one, mimicking her original drawing. Now to mimic means you kind of do the same thing, but maybe not exactly. We're not sure if this is an exact copy or if it's to scale. We're going to figure that out. First, we're going to state the coordinates of the vertices and fill in the table. So here's our table. We're going to take the original drawing and we're going to find the height and length of it. And then we're going to take the second drawing and find the height and length of it, and then we're going to compare them. In order to find the vertices, remember we're going to do X first. We're going to count over 7, and then we're going to count how many up, which is 18. So this point right here is 7, 18. 7 in the X direction, 18 in the Y direction. This point over here is 13, 18. 13 in the X direction, 18 in the Y direction. The point down here is 13, 0 because it's on the x-axis, so it didn't go up any. And this point is 7, 0. Now we need the points of the other drawing. I'm doing the same way. We have 7 over, 9 up. Then we have 10 over, 9 up. We have 7 over 0 up and 10 over 0 up. So those are our coordinates. These are the vertices of each part of our drawing. These are corresponding points. The point 7, 18 corresponds to the point 7, 9. Now I need to find the distance between the points. I can either count the squares, or I can subtract either the x or y values, whichever set is different. So in order to find the height of my original drawing, my x values are the same, so I'm going to subtract my y values. 18 minus 0 is 18, so the height of this drawing is 18. Then to find the length, I'm going to look across. I can either count 6 squares, or I can see that 13 minus 7 is 6. So the length of my original drawing is 6 units. The height is 18 units. Now I'm going to do the same for my second drawing. It's 9 units high, 0 minus 9, and it's 3 units wide, 10 minus 7. Now, I need to see if this is a scale drawing of this one. The second drawing is a scale drawing if the value of the ratio is the same for all the corresponding segments. So the height in our original drawing corresponds to the height in our scale drawing, or my second drawing anyway. And the length corresponds to the length here. So I'm going to see if the ratio between the heights of the first and second drawing and the lengths of the first and second drawing are the same. The height ratio, my original drawing to my second drawing, is 18 to 9. My length ratio, my original drawing to my second drawing, is 6 to 3. I'm going to find the value of each of these ratios. The value of the second drawing, or the ratio from second to original, remember y to x, is 9/18, or 1/2. The length ratio is also 1/2. So I know that the drawing that Celeste drew was a scale drawing of her original one. The values of the ratios are the same for height and length, so the second drawing is a scale drawing. In the exercises today, you're going to be working on determining whether or not it is a scale drawing. Make sure you filled out all your notes, and we'll see you in class.